Take it, for example, Amazon, and they do this, and some other supply chain logistics companies. So you have to deliver parts to customers, maybe abroad, especially maybe for, it could be for the DoD, for example, DoD, the Department of Defense in the United States. So we have soldiers that are in battlefront, and sometimes due to supply chain and options, we can't get some of these materials to the soldiers on the battlefront. They need to be able to make these materials, make the parts. It could be parts for their guns, ammo, whatever they need to get going. And they use additive manufacturing to produce those parts on site, and that takes away the supply of having the materials to fly from the United States all the way down to Iraq or whatever they want to, they need it for. So this is a very, this is one example of on-demand manufacturing, and also sustainability. So now, how does additive manufacturing work? So like I mentioned, you have a card file. You slice the card file and you send it to the printer. The printer is usually like a printer like in this form, and it prints that card model. So a lot of this is used for learning, even in K-12. K-12 is primary, nursery and primary school, where we can teach kids how to print their toys so they can design their toys and bring it to life using additive manufacturing. So another part of the process is the post-processing. Now, depending on the type of the additive manufacturing technology, the printed material may need to be cleaned, it needs to be cured. Curing just means for polymers, especially for thermoplastic polymers, needs to be cured, meaning they need to be hardened. And we have, most other post-processing part, it means it needs to be polished, and it also needs to be assembled. And there are many types of this process, and we'll quickly go through this. One is that polymerization, which is just using what we call a photopolymer resin, and this would selectively cure using a UV source. And there are examples of this process like SLA, DLP, and some of the key advantage of this process is that it has a high precision, it has a good surface finish, which is what we need in additive, especially when we want to use smaller parts. Now, we also have the material extrusion. This is what we have here. The FDM is a material extrusion process. So, and FDM, like I said, is also called the FFF, which is the fused filament fabrication, which is the common printer you see here, and that's what we have here. And that is what I'll be talking about on my case study. And we also have the powder bed fusion. We have the powder bed fusion it's a very expensive process, but it uses metals instead of polymers. And it fuses the metal powders together to form under very high heat to build the powders into these parts. So the next one is the sheet lamination. It's just using flat paper polymer metals and binding them like in sheets, typically using a laser or a blade, and it's laminated together to form the parts. Now the next one is the DED. DED is direct energy deposition. It uses laser, it uses electron beam, and you can use plasma to melt the material. Now next slide. Now, all these processes do have the advantage. Well, I'm going to talk about the FDM process specifically. Now, which of these following is not in recognized type of additive manufacturing according to ASTM standard. Now, before I come to you, can someone tell me what ASTM stands for? Good. Yes. What's your name? Good. American Standard for Testing Materials. So that's ASTM, and I'm part of ASTM International under the additive manufacturing group. So what we do is that we review standards internationally and globally and update the standards frequently so we can have a standardized ways to manufacture this, to use this technology to manufacture parts. If you don't have a standardized method, then it means that I can make this material in China and make this material in America, and I'll test these two materials and they have different properties. The next thing we're going to talk about is the impact of additive manufacturing and AI in Nigeria. So, there are a lot of advantages, okay? Education, skill development, I went into some of the innovation centers here, and there are, learning tools that you can make. 3D printers and AI platform can introduce students like yourself to practical application in engineering, especially things like design for manufacturing and technology. And STEM education is another one, affordable printing process. These printers are, not too expensive compared to some other additive manufacturing printers that could run into millions of dollars. Some of these FFF printers could be as low as a few hundreds of dollars, okay? So other application will be healthcare. Customized prosthetics is very useful for that. And we can use that for medical device applications and manufacturing, and also in bioprinting. We can print even using cells. We could print using soft tissues and soft polymers as well. So some of the challenges and opportunities in additive manufacturing, like I mentioned, is the slow process, it's expensive as well. And some of the opportunities that it bringing these days is in material research, skill development, and even regulatory framework, meaning that we can have certification standards of the manufactured parts, and it can bring opportunity in standardization, like I mentioned, using in the ASTM. So in terms of Nigeria, we are looking at infrastructure, access to technology, skill gap, and education. There are other opportunities, especially in Nigerian universities, part of the reason why I'm here, and in startups and industries to lead to AM innovation. So it's a great area to keep in, and it's a great area for workforce development. And this slide, I just used it to show some future of AM where it combines everything from your creativity to your application to your design and everything. So great for workforce for the future. Now, of course, the goal, like I mentioned, is to have an informed, optimized process parameters so we can have better printed parts. How many of you have heard of digital twin? It's a buzzword as well, like AI, right? Digital twin just means that I have a system and I want to twin that system and replicate that system in a digital form. And that digital format of that system is going to do the same exact thing as that physical process and help to modify that physical process by running
by taking the physical process parameters and doing what we call doing different optimization on the digital side and doing an optimization round process, and then we get the best parts. For example, if it's in manufacturing, and that is a simple capture of what a digital twin is. Now, another thing that we can do between Texas A&M University and University of Lagos is to create an undergraduate pipeline exchange program. So I'm sure most of you know what an exchange program is. So we can have a pipeline where you can have your year one, year two, year three here in the University of Lagos, and then you have your fourth and final year at Texas A&M University. So I'm working with the team to see how we can make this possible. So that will be very exciting to have some of you finish your undergraduate program in College Station, Texas, right? Along with the undergraduate exam, you can look me up on Instagram or LinkedIn. Now, this will help you navigate the US graduate school application process, right? It's a very daunting process, as you can imagine. I did my graduate application I started maybe 13 years ago. That was when or 14 plus years ago, that's when I thought, okay, I want to do a PhD program. I went online to find help. There was no much I could do. I needed to fill in forms. I needed to write something called a statement of purpose. And I needed to get letters of recommendations. Right? There are a lot of things that are required to get into a graduate student program. And if you don't have a competitive, you can imagine, I would usually tell you that I get about at least 10 emails every day from students all around the world asking for, hi Professor Felike, I want to be a graduate student, I want to do a PhD or a master's, I'm interested in an academic or something else, right? If I get that much application, or if I get that much email, you would imagine what the application looks like. So the application pool is a competition. You have to stand out in your application, meaning that you have to have the right statement of purpose, you have to have the right recommenders, your application needs to be outstanding.